Really happy to be here. Thank you everyone for taking the time out of your day to learn why we should have testing in mind when building a CD pipeline. Now, my goal and the message that I want to make clear to you guys is when jumping into CI/CD, you really have to take a step back. And I had a good conversation with my friend Jonathan Lips, and he talked about this at his presentation or keynote. But in philosophy, he frequently says, he asked me, what makes you happy, or what do you want? And I was a big house in Palo Alto, and maybe a Tesla. And he's like, take a step back. Why does that make you happy? In the same sense, we all want continuous delivery and deployment, and we know that's where we need to be and what we need to implement to keep up with our competition and to deliver quality code frequently. But before jumping into it, let's take a step back. Why? And make sure we have the prerequisites in place such that when we do get our pipeline in place, we get the most amount of reward and utility out of it. And specifically, what I've seen in the industry is folks don't figure out how to run tests in parallel, or atomic and autonomous testing, or deployment strategies before they jump into CD. And eventually what happens is they get late feedback or no feedback, and then you get the feedback from production because everything is automated all the way through to production. So real quick introduction about myself. I serve as a solutions architect for Sauce Labs, and what I help do is help our customers onboard onto test automation, explain what the benefits are, run our professional services organization, as well as evangelize and make sure the customer and the industry knows why test automation is critical and needed. But we're all here for the same purpose because we know we have to get there with automated testing in order to get to continuous delivery and deployment. Prior to this, and shout out to some of my Yahoo friends in the back, I worked on Yahoo Mail as a front-end engineer and a quality engineer. I assembled the test automation framework, which Yahoo Mail still uses today, and with the help of my friends out there, the CD pipeline, which pushed everything to production all within the same day, if all the tests pass. And you guys can imagine how critical the testing is, because if it doesn't pass, it's going straight to all of the many, many Yahoo Mail users. I went to UC Davis and studied computer science and engineering there, and that's where I got the start to my computer science career. So the overall flow of today's talk is, first I want to talk about the importance of testing, the role of testing in continuous delivery and deployment, why it's so important to get testing right, and what happens specifically if you have no test or have flaky tests or an inverting testing pyramid. Then we're going to move on to what do developers want from automated testing and within continuous delivery and deployment. Specifically, testing and isolation, meaning that they're getting feedback regarding their code changes in an automated, isolated fashion, such that it's not affecting it's not being merged into the master branch, blocking the build, therefore new changes can't get out, everyone's debugging the build. So I'm going to talk high level about what developers and the team wants out of continuous delivery, specifically shifting left and testing early and often. And then lastly, rather than talk about this, because as engineers we like working code, working examples, I'm going to show this, which is essentially a prototype of the pipelines that I'm seeing in our most advanced customers, including Yahoo, in the field. All right, so let's go at it. So what happens if, this might sound absurd, but just bear with me for a second. But what happens if you have a CD pipeline without any testing? That means you're building the code, you're not testing the code, and then you're deploying the code. That means without any sort of quality checks or any mechanisms to tell you A, B, and C feature is broken, or you regress X, Y, and Z feature, you're automatically pushing into production. So who's losing at the end? You and your customer. The customer is experiencing all different types of bugs that they were not aware about, and eventually will get turned off to the experience. Or something that previously used to work did not work, and things are changing behind the scenes without any regards to quality. So obviously, we need testing if we're going to do continuous delivery and deployment to make sure our application is quality code, that it functions appropriately in all the browsers and operating systems that the application supports. So you need to write all the tests and get them running across all the various platforms and operating systems and mobile devices, emulators, simulators that you support, such that you know this is quality code and can move it across the various environments. So now, obviously, we know that we can't have CD without testing. So what about what happens when we do that? The best analogy that I like to use, and it's very relevant in one way and also irrelevant, but I like comparing delivery pipelines or developing and delivering software to developing and delivering cars. The difference is software is flexible, so excuse that, but the components make sense. Software is made up of different components. You have the front end, the back end, the middle tier, the databases, all the other different moving parts. They all need to come together, and you need to test them. And if you don't test them, then you don't know which features are working, which ones are broken, as well as when things are broken, which component was the result. So what happens if you have an axle, a wheel, and a body of a car, and you don't test any of them at the unit testing level, meaning each individual component, or the integration between the axle and the car. And then you don't even test when you assemble the whole car. Well, you end up with a bum experience like here, and a very upset user, and also no utility. Here we see a car being towed away. Similarly, if we don't test and we deliver all that code to production, we deliver bum software. So another example that I'm seeing is as the industry is moving from manual to automated testing and trying to decrease dependency on manual testing, they're moving straight from manual testing all the way to end-to-end functional testing without visiting unit or integration testing. So what ends up happening is you've automated all of your manual flows and have a huge end-to-end functional test suite. That's great that you have now a safety net that is blocking, any broken features or broken functionality from going to production. But what's happening is if you have an inverted pyramid, as demonstrated here, meaning heavy on the functional testing since you automated all your manual testing into functional testing, and then very little, and sometimes none. You'd be shocked. I've seen none sometimes, no integration testing or unit testing. But what ends up happening is you are catching the errors before they go to production, assuming that you have automated all the manual tests. But then when it comes to figuring out what went wrong or what was broken, you're now debugging the entire car, the entire application stack. You don't know if it was the axle or the tire or the wheel or the engine that went wrong. Or you don't know if it was even the integration of the engine and the axle, or the wheel and the axle, better example. But it's the whole car that was broken. Now I have to figure out what went wrong and debug the whole car or the entire application stack. So yes, you can achieve continuous delivery and deployment with heavy reliance on functional testing and automating all your manual flows into functional tests. But what will happen is every time something goes wrong, it'll be caught very late. Also, for functional tests to run, it requires compilation and deployment. That process can sometimes take some amount of time, whereas if you can catch something in a unit test, you've now isolated that error to a specific component, to a specific unit of code. And if you're running that unit test within the browsers, you've isolated it to a unit test or a particular unit of code that's not working in a certain browser. So now you've isolated the error even further. So what we do want is a regular testing pyramid where there's unit testing very heavily, and you have some type of code coverage metric that certifies that, and then a balanced amount of integration testing, making sure your two components, or more than two components and units, are behaving well with each other. And then lastly, functional testing for exercising the whole stack and being very smart about the functional testing that we're doing. Also, when you have a lot of functional tests and you've automated your manual tests directly into functional tests, you have very, very, very long tests that are brittle, that are prone to breaking, and sometimes are doing more than the test would. And I'm going to talk about this later when I talk about how tests should be atomic and autonomous in regards to functional testing. Anyone here experiencing very long functional tests that are sometimes brittle and hard to maintain? A few? Okay. So really think about that. And for one, they could be flaky for a variety of reasons, which I'm going to go into. But think about, can I have a unit test or an integration test that would certify some logic and give me the confidence I need whether this functionality is working or not, and then have an appropriate functional test for that. So once again, what's happening is manual testing to automated testing is sometimes resulting in an inverted testing pyramid, a lot of functional tests, and that's not the test strategy that we want or is sustainable, and not what developers want, as they want to isolate the error and effectively remediate in as little time as possible. So something that will doom your CD pipeline is flaky tests. Me as a developer, if I issue a pull request and change X component of the code and Y and Z fail, and I know that X component has nothing to do with Y and Z, I'm not going to get my code merged in not because of broken functionality or bad code I wrote, but because I had flaky tests, and that isn't giving me the confidence that I need when everything that's working. And what ends up happening is that you comment out that test and keep on moving on with the pipeline. And that's a complete failure of the system. Someone put the effort into that test to write it and make sure that some functionality was always working. I tried to get pull request A in that had X functionality that was unrelated to Y, but now I took the quality check out for Y. The other piece is, even if you're not running on the pull request level and later in the pipeline, if tests fail in no predictable fashion, everyone loses faith in automation and loses faith in testing. And that's where the whole system collapses and people start reverting back to manual testing. So one, testing best practices must be addressed and standards must be set before we jump into automated testing and continuous delivery and deployment. Because one flaky test now, you might have 5 as you scale up, 10, and these are issues that will doom developer and the team's faith in automated testing. And here what you see is a graph, and this is exactly what I don't want to see when I look at a build. But if the code didn't change and I run this same build over again and I have a different number of failures, that means one, my infrastructure is flaky, my tests are flaky, or my application code is flaky. In that sense, I'm never going to have confidence or 100% confidence to release to production in that sense. Also, how continuous delivery and deployment work is the next build gets triggered if the first build succeeds. So now I've blocked the pipeline here, and everyone is debugging flaky tests. Okay, so what do developers want? They want a mechanism such that they can get feedback regarding the code changes that they made, not everyone else's code change, just their own isolated code changes, and they can have tests run against them and certain enforcement acceptance criteria that must be met before we move on later with the pipeline. So as a developer, I want some mechanism where I can trigger all the tests, or automatically all the tests will be triggered against my code changes. And if everything passes, if I've not regressed anything, if I've written appropriate unit testing, appropriate functional testing, my source code is performant and written correctly, then, and all the tests pass, only then do I get someone to code review it and merge it in. I don't want to waste anyone's time code reviewing anything that is going to break functionality or is going to cause a regression. So really want to be cognizant of everyone's time and the process, and as a developer, I want to know whether my code does or does not work in IE10 or I regress some feature. One of the best mechanisms for this is called testing in isolation. Sometimes this is implemented as a pull request build, but developer issues a pull request that webhooks into CI and runs through the acceptance criteria. In this example, it's going to be unit tests and functional tests, and I'm going to have a couple other mandators or checkers in there, which I'll talk you through. If everything is good, I get the safe to merge stamp. I have 1 or 2 peers code review it. They give me a thumbs up. We get it merged in, and then move on with the later stages of the pipeline. Is anyone executing functional tests on code review today here? I know there's a couple back there. I see some here. Unit tests on code review or pull request? Okay. That one's a little easier because you guys don't have to compile and deploy. But to gain full confidence on my branch or pull request, all the tests must need to be run. Sometimes that's difficult because it might take 20 hours to run all the tests. But that's why we need to parallelize and create these small atomic autonomous tests that we can run massively in parallel. And in a utopic ideal world, you'd be able to run all of your tests massively in parallel against your feature or code branch to get 100% confidence that everything is working, no regressions in all the different browsers. The state is different. For example, I've seen organizations where, hey, we want the pull request build done in 10 minutes because we don't want to wait around all day and get this code merged in and deployed to production. So it's a balancing between the business requirements, developer confidence, and other moving parts there. So I'm going to demo a great deal of this using Jenkins as my orchestration or CI engine, GitHub as my source code management tool. I'm going to be using Angular for my source code. For testing Angular on the unit level, I'm going to be using Jasmine and Karma. And for functional testing, I will be using Protractor, which is Angular's end-to-end testing solution and essentially serves as a layer on top of Selenium WebDriver. I will then be Dockerizing my application, deploying it local, or containerizing my application, deploying locally, running tests against it. If everything's okay, then we'll get that merged in, and it will then be pushed out through to production. And at any moment, if you guys have any questions, just speak up and I'll try to address that. All right. So first thing, I'm going to act like a developer, pick up my task, and start working on the source code. So let's go to Trello. Oh, we got it right here. Let's go to demo. There's this task right here that says remove last data. So I have this application, and here it is on production. It's just a dummy AngularJS app. You can click tab 1. It takes you to this view 1, and you click add data, and the data gets put in there using AngularJS as two-way binding. Now, what this task right here, remove last data, means is I want to add a remove last data button here, such that when I click it, it'll pop the last entry in this table. And I'm not done until this change gets pushed out to production. This EC2 instance that I'm hitting right now is production. So here I should see the remove last data. I cannot move this task to done/deployed until it hits production. All right, so let's go at it. Go here, spin up my local Python server. Go here. Here we got a Python server. And when I click tab 1, we can see that there's nothing in here yet. So let's go ahead and implement this functionality. So let's go here. Here's view 1. So here we added in the markup for remove last data. So that means when I spin up my Python server here, that I should see a remove last data button whenever this refreshes. And there we go. And obviously it does nothing because we didn't write the JavaScript so far. So let's go ahead, write the JavaScript. So here we go. We got remove data, and then we got remove last data. So just to summarize, here is the UI element that has the binding for clicking remove data. Remove data is in the controller layer, which reaches out to the service layer to call remove data. And what remove last data will do is just pop the last entry in the table. So now let's give it a test. Refresh, add data, remove data, everything's okay. All right, so as a developer, I may think I'm done. So I'm going to go ahead and issue a pull request. So let's go here. I'm going to be doing all my Git magic through Sublime. So create a new branch. See what changed here. We got the view and the JS. I hope that your guys' GitHub commit messages are more clearer than mine. Go ahead and push this up. And now we're going to issue a pull request. So let's go to our repository. Here we see a new branch was created. And let's go ahead, check this out, and issue a pull request. How's the font? You guys can see? Yeah. OK, thank you. Create pull request. Now, as demonstrated in this diagram, what's going to happen is issuing that pull request will webhook into CI and run through my acceptance criteria. And the point of this demo is not to specify any technologies. It's about the approach. Now, it doesn't matter whether you're using Bitbucket or Bamboo or whatever. It's source control management system, hooking into CI, enforcing some criteria. So let's go back here. We can see some pending checks haven't completed yet. And let's go and see exactly what's happening within that build. It's going to go ahead, launch Sauce Connect, and then run make all. So what make all consists of is setup, static code analysis, unit tests, and functional tests. So I'm going to run JS hint to make sure that I have my semicolons and I'm following the appropriate JS standards there. I'm going to run unit tests. I'm using Karma and Jasmine, as I mentioned. And then it's going to run through this code coverage script. This code coverage script will look at the old code coverage for the unit test and the new coverage, and then raise an error if code coverage has diminished. So in this example, what's going to happen is I, as a developer, have introduced new source code without writing any unit tests. This build will run the unit test, first tell me if I've regressed anything on the unit or component level, and then alert me that I've decreased code coverage. I introduced new JS without unit test code. So now I need to go back and write the unit test for it. So quickly, let's take a look. Here the unit test executed, and we can see this error got raised, and it says code coverage check failed because of drop in code coverage numbers. Now, the old coverage was 100%, and 100% is absurd. I don't think any project should have 100%. I accidentally achieved 100% code coverage because this was like a 30-line app, and a couple unit tests hit all the lines. But for an enterprise or a bigger project, 80% I've seen is kind of standard. So here it failed. On my pull request, I can see that this failed, so I can't get anyone to code review this. So the only thing I've done in my demo is move this to in progress, and I'm working on it, but I'm by no means done. Even though the JavaScript and HTML are written, this is not deployed to production, and it hasn't been deployed to production because my acceptance criteria has not been met, meaning my build has not passed, my pull request build. So let's go back and go ahead and write a unit test for it. So here's a unit test for remove last data. We'll have 41 and 42 in there. This one will add 8 and 9. And then this test will call remove data, making sure only the original 41 and 42 are in there. So let's go ahead, commit this. Push this up. And this will retrigger the process. Now, if that pull request build that I'm running took, as I mentioned, many, many hours, this whole exercise that I'm doing right now live would have taken all day, maybe all of SauceCon, and you guys would have gotten real bored with me real fast. But the point is, these tests are executing quickly. I've scripted my deployment. I'm containerizing, and I'm getting the feedback that I need as soon as possible without affecting all the other developers, as this is on my own feature branch. Now, some of you guys may ask, who's writing the tests? Like we have two separate departments, dev and QA, or SDETs and front end. But it really doesn't matter who's writing it. The point is that tests are being written up front and included in the branch, that they're a first-class citizen. And one of the prerequisites here that I'm going to get into later, you can see I have my source code and my unit tests all within one space. And that is the reason why I'm able to make sure I'm introducing unit tests, and I'll get to it, but functional tests, all at the time of source code being introduced into the repo. So once again, this triggered the process. Let's take a look at what's happening. So now unit tests pass and code coverage checks pass. It's moving on to functional tests. It's first going to containerize my application and deploy it locally, and then run functional tests against it. I have 6 tests and 4 different browsers I'm running on. So here we're counting 1, 2, 3, 4, 5, 6 functional tests. And they're pretty simple tests. Put in 13, 14, click submit data, verify 13 and 14 are there. And I have 4 different browsers that I'm testing on here. So 6 times 4, 24. All these tests are executing in parallel. If we look at my build, they're still running. And as a developer, I will get my feedback that I need. So now we've written the unit test. We know that all the components are working properly, including the new component I wrote, remove last data. And then, and only after we know all the unit tests are passing, do we move on to the functional tests, and also after we know I wrote the unit test and achieved the code coverage that I needed to meet. So all these tests are running. Seems like they're passing, and everything's good. Now, I think I'm ready to merge in my code or have you code review it. Oh, nope, just kidding. It says, error, need functional test for new feature. So basically, what went on is I wrote a quick Ruby script here, which said if I change the controller, the services, and the views, that means I probably introduced a new feature. That warrants a functional test. There's various different ways of detecting whether a functional test is required, but this is one quick one. In an enterprise environment, it might be different, but a quick check to verify if a new feature was detected, and if you can figure that out, that usually warrants a functional test. Is anyone doing any of this today, enforcing that functional tests are written? So this is a new trend that I'm seeing, because, yeah, typically, tests are written later. But now what we're seeing is we need to shift left and test our first-class citizen. All code is treated equally. So even in this process, when I introduce a new unit test or functional test, that's also going through the same process, this pull request build. And the build is also certifying not only my source code, but my test. So I can't check in a broken test here. And what I'm also seeing in the industry is in eliminating flaky tests, if a new functional test is written, they're doing static code analysis on the functional test, making sure best practices are followed, and also rerunning that functional test some amount of time to make sure that it's not a flaky written test and it won't ever get into the main build and cause flakes. So addressing flaky tests as early as possible and not letting them in rather than having them get in and dealing with them.
So what's the difference between your unit test and your functional test?
The question was, what's the difference between my unit test and my functional test?
Yeah, are they similar enough that, are they different enough, I should say, that they want both of them to be there?
Good question. So with the unit test, I've just verified that the JavaScript that I wrote for remove last data works properly. So basically the data.pop. But in the functional test, I'm verifying my whole Angular stack and the new functionality, as well as the customer experience, right, in the browser. I don't know. I know that the JavaScript for remove last data is good, but maybe the UI element is hidden. It could never be clicked. That would never be caught in the unit test, correct. So unit test, making sure the code I wrote is written properly and performing properly. Functional test, does it actually work in the context of the whole application and in the view of the user, in the eyes of the user? Any other questions?
For your pull request, do you test the merge of your branch in the upstream, or do you just test your branch?
Good question. So what the pull request build should do is it should pull from master and test against the latest. In that case, if you're going to have conflicts, it's never going to get merged in. GitHub will usually detect that because the branch you're merging into has conflict. But the point is, you're not just testing your change in isolation, but you're testing your change in isolation with the latest snapshot of master. Now, if we go back to this diagram, you can see that the test will be run one more time right here as well. And this is, in the case that 2 pull requests are spawned or merge in at the same time or near the same time, that's to test the integration of the two. And so that's the point of true continuous integration right there. The other squares are pull request builds, and we're testing in isolation, but that's not truthfully where everything is integrated. Yep, absolutely. So what do? We got to go and write a functional test, because if we look here, we can't merge this in yet. So let's go ahead and write a functional test. So this is the functional test for remove last data. We're just going to our application under test, putting 33 and 44 in there, clicking remove data, and verifying that 33 and 44 are not present. Any questions about this piece? All right, so I'm going to go ahead, add functional test for remove last data. This, once again, will trigger that process. And something I want to bring up is I hooked everything here up from scratch, and Sinjin back there is going to talk about it kind of more how it's done at Yahoo, but it was really easy for us to kind of achieve this at Yahoo. We had a system in place where we could just define what steps needed to be done in our pull request, and everything would be wired up from scratch. So also think that when you guys are going to go down this approach, not just for your team or just for your product, but how to scale something like this. For example, you can see if there were a bunch of different pull requests, that would require a lot of different infrastructure in terms of build and deployments and such. And the reason we essentially moved to something like this at Yahoo is because we were debugging master and debugging the QA build, but so many commits, so many different pieces of work, so many different moving parts went in to that build. It was so hard to narrow down on what was the offending commit or what was the piece of code that actually broke the build. Meanwhile, if we could avoid that piece of code ever being merged in, or only being merged in if it met the acceptance criteria, we would save time on debugging, and we'd be productive within our text editors and CI, writing code and deploying builds. So here we go. We added the functional test for remove last data, and let's take a look at this build. The functional tests are running, and we can see them all flushing out on sauce as part of the new remove last data functional test should have run as well. Let me see if I committed that. And here, we should then see everything pass. So now if we look here, we should see our new test if I committed it properly. So let's take a look at the functionality. Remove last data. And so that test would have run within this build. And now I've certified that everything works, meaning both on the unit test level and the functional test level for my new feature. Now I can then have you guys code review this. Here we got the controller, the service layer. We got the new functional test for it. We have the unit test, and obviously the markup. Now, if we get thumbs up on this or you guys approve, we can then merge it into master, which will then trigger off the production push. Now, we've tested this in isolation. We've tested against all the different browsers, and we've done unit testing and functional testing. And we ran all of our unit and functional tests. So I have full confidence that when I push this to production, assuming I push the same Docker container, it will work. So let's go about that. And keep in mind, I'm not done. Even though I wrote all this code, it's still not pushed to production, right? So anyone have any objections against this code? Yeah?
Since you're using hard-coded data values, it never fails on the review step, or you have a persistent data ID versus table.
Yeah.
That will always cause
Correct.
it to fail because it'll always be present even after it's successfully.
Yep. So yeah, this is a prototype application. In some senses, there's a lot of optimizations or things that I maybe should put that value in a YAML file or some type of config file, or read from that, or do data-driven testing, or set up. But absolutely, so never hard code your values. Absolutely, especially in any enterprise production application. That you're right. I could change source code, and that didn't mean that the functionality is broken, but the functional test for that, or the unit test, could break.
Right, yeah. You just randomize the value based on context.
Yeah, absolutely, and that's the right way to do it. Some type of data-driven testing, whether you have predefined values that get fed in, or randomize it to actually reflect user behavior. Absolutely, correct. So now this is good. Let's go ahead, merge this in. And now what's going to happen is it'll trigger one more process. And it's this build right here. So this is this guy right here, which will run through the acceptance criteria once again, the point of continuous integration. If everything's okay, it'll then push to production. So automatically, I should see production reflected with my new remove last data ability. And if that's true, then I can move my task to done and move on to the next task. Luckily, my Trello board says it's empty, and we're hitting 5 o'clock, and we got a nice event tonight. So here's the QA build that serves as my production build in this demo. The unit test pass, it's running functional tests, and it's going forward with that. And now, if everything passes, it'll then push to production. So let's let the functional tests flush out. Any questions so far? So what I'm going to get into next is what does it take to do something like this? This was quite simple because it was a prototype application. There really wasn't a database associated, no test data management. And deploying it was really easy. All I did was do an npm install and then Dockerize or containerize that and deploy that appropriately. So in a production environment or a corporate enterprise environment, you have to figure out your deployment strategy. For something like this to work, to run functional tests on the pull request on each feature branch, you must be able to deploy each feature branch programmatically at runtime on the fly. So here, I was able to deploy locally, run tests against it, and then move on. Whereas at Yahoo, every pull request build that we did, it would take a production-like VM or a QA-like VM, deploy onto that, and then run tests against it. So if there are 50 pull requests, we need a way to spin up 50 hosts to deploy to and run tests against. So you must figure out how to script your deployment and deploy the whole entire stack or the pertaining portions of the stack on the fly. If that's not done, you can't test on the fly. And that's where we see ourselves getting into nightlies and scheduled builds. But really, what we should be doing is running tests every time the code changes or every time the developer or someone asks for a code to be changed, such as in a pull request. So now all these tests ran, they've passed, and it ran this downstream build. We can go to here, refresh. Here we see remove last data. And I know that it's going to work because I've tested it, both unit and functional, in all the various browsers. So now, we code reviewed this, we had merged this in. Now we are finally done and deployed. Any questions about being done?
What about non-functional tests, like performance tests?
Exactly. So in a utopic ideal world, you'd be able to run every single test that you ever have against the pull request. And performance, even XSS and security and things like that. But really, one, figure out how long you want this build to take. And then jam-pack everything that you can into there. That's really what governs it. Now, you're going to take from, what breaks the most often, right? So if performance or security doesn't break too often, it's okay to run that on QA at the point of continuous integration. But if your unit tests are breaking or your functional tests are breaking and you're causing regressions, it makes more sense to run those type of tests in that. So it's going to be different for the product you have, whichever space you are. Maybe if you're a performance product or something, obviously the performance is very important to you. But someone like e-commerce, it makes sure that what's really, really important to them, can the customer check out? Can the customer add something to cart using this browser, and this browser? So it varies upon the business and all that. But jam pack all the testing and execute them all in parallel. I'm not even just talking all the functional tests in parallel, but if you can do the functional tests in parallel as well as the unit tests in parallel, there's lots of different strategies here. For example, we can check out EC2 supercomputers to run the functional tests in parallel. And then meantime, some other execution of other tests is happening. So it's about how much can you get done, how fast, and what level of confidence do you want going forward. And one more slide.
All right. One more. We're like 4 minutes over.
4 minutes over? One more.
Yeah.
All right. So lastly, just deploy on the fly atomic autonomous tests. Otherwise, you won't be able to run in parallel. Then you'll have resource contention if you're all using the same user in the same test. Atomic tests to be more stable so that the tests aren't lengthy. And lastly, the message I want to leave you with is enforce, don't police. Check for these things up front so they're not a problem later, and you guys can stay productive within your text editor, CI, getting stuff done. That's it, Manny.